Okay, so we've talked about an introduction to algebra. We've talked about algebra, what algebra is, and we're going to kind of revisit some of that. And today, we're going to talk about what makes algebra and arithmetic different. And we've done this a little bit before. Remember that in arithmetic, you have the four operations. What are the four operations in mathematics? Add, subtract, multiply, and divide, right? Okay. All right, add, subtract, multiply, and divide. Now, there are really no other operations in mathematics. You can do things differently, all right, but even the square root is really just long division. It just wants you to divide something by what? Itself. So it's even if you look at the symbol. Look at the symbol for long division and the symbol for square root. They're the same except for that little tail on it, right? Which tells you that it wants you to divide by a specific type of number.
What's in
10? So then using in trigonometry. Okay, so four operations, but in arithmetic we only worked with numbers, 5, 7, 9, etc., right? But in algebra, we have a new building block, something else that we use. Do you remember what they're called? Variables, exactly. And today's lesson is all about variables and how they're used. Now remember, variables are just those letters. And all they stand for is some unknown number or value. Yes, good. Okay? But it's a lot easier to write a letter or a symbol than it is to write out the phrase some unknown number. Right? Okay? And that's why we simplify it to use X, Y, etc. Some letters we don't use very frequently, except for specific cases. C is sometimes used, but what does C stand for? Do you remember when we were it stands for, if something is always the same, it is a constant. So C is a variable, but it means a constant. So that means it's always just some straight number. Whereas Y or X could be a whole algebraic expression. All right? Now, we also, in the last section, hopefully, we talked a little bit about M. Do you remember M is used to represent the gradient or slope of a line, right? So sometimes some letters are reserved for special uses. Now, that doesn't mean you can't use them for other uses. It just means that later it might get confusing if you do. All right? So what we're going to do is we're just going to run through this Education Perfect exercise again. So remind you about the variables and to strengthen your idea of what algebraic expressions look like. Okay? And then we'll go from there, and you'll use the rest of the term to build the algebraic system some. Okay? So, let's look at... Okay, so today's lesson about algebra. Remember that in algebra, we can use... The only difference between algebra and arithmetic is we use letters or sometimes symbols to represent numbers that we don't know yet. Okay? And so we're going to talk a little bit about that and some of the conventions behind using them. Okay? So, in order to get you used to using variables, we're going to start work by looking at a little example. And the example they use is sailing. So you remember this one, I hope. We had the motorboat. It's got this boat with a sail on it. It has a motor that goes at a constant speed. And I call it a constant because it's a number, right? What is the constant speed of the motor in this case?
10 knots.
10 knots, right? And so it is a constant. It can only be 10. Good. And then the wind speed can vary. Can it? Is it always the same wind speed outside? Absolutely not. You Wellingtonians certainly understand wind speed, right? Okay? So wind's always changing. And so since it varies, we call that a variable, right? Something that changes. Now, can you measure the wind speed as a number, though?
Yes.
Sure. But that number is going to change depending on the speed of the wind. So here they're talking about total speed. So this is an example of an equation. Because it has the equal symbol, it's called an equation, right? Equals gives you equation. And the equation is that the total speed of the boat is equal to 10. Where'd they get that 10?
From the motor.
The motor, the speed of the motor, plus the wind speed, right? But instead of having to write plus the wind speed, it might be easier to write that using a letter. And what letter might you use to represent wind speed? Yeah, W makes a lot of sense, doesn't it? To use a W for it. So we could say that it's 10 plus W. Good. What if the wind speed was 0? Would that change how fast you were going? No. But if the wind blew very hard, then it would make you go what? Faster. Excellent. Good. Okay. So, if the wind was 20 knots, 20 plus 10 would give you a speed of 30 knots, right? What if it was 15 knots? 15 plus 10 would be 25 knots, right? 25 knots. So it's just a matter of adding it in. But you see that it can change or vary all the time. And one of the reasons, so we could write that as 10 plus W, where W simply stands for the speed of the wind. Good. All right. You don't have to use W. You can use any letter you want to. You can even use symbols. You'll often see Greek letters used as symbols for unknown quantities. But generally, we like to use names or letters that represent the items that we're working with. Right? So, how about for number of bananas? What would you choose? B, sure, because it's a very descriptive item, the word for that, right? Okay. The next thing we want to talk about is we want to talk about an expression. An expression simply means that you have some combination. Okay, so let's go ahead and just write that on. So an expression is simply a combination of numbers, and remember numbers are called constants, variables, which are the letters, and operation symbols. Okay? What they do not have is they have no equal symbol. And you can call it an equal sign if you like, but in reality it's a symbol. Do you know what signs are?
Yes.
Positive or negative, right? Those are your signs, right? So an equal symbol is really a symbol. But they don't have an equal symbol. If they had an equal symbol, then they would no longer be an expression, but an equation. And those are two different types of mathematical problems or sentences. Okay? Good. All right. Now, so say, for example, we have twice the amount of wind as before. Well, twice means multiply by what number? 2. So if the wind was W, twice means take 2 times W. Right? So that's an example of an algebraic expression.
But how are you supposed to do it when you don't know what the W means?
Well, it doesn't matter. You just double it. I understand that makes no sense. But let's say that we had a machine that could double the wind speed. All right? So if you turn on the machine, no matter what the wind speed was, it would double it. Okay? You're exactly right. How could you double something that you don't know what it is, right? Okay?
You learn to ignore it.
But you could say something specific like I could say that Audrey is going to give you some ice cream so that you do a favor for her, right? But I'm going to give you twice as much ice cream if you do the favor for me, right? So we don't know how much she's going to plan to give you, but whatever it is, I'm going to double it, right? So once you find it, then you can double it. Good question. That's an excellent question. And one of the things about teaching algebra that makes it difficult, because when you think about it, people who, like me, who have done a lot of algebra all the time, just think about it quite easily. Have you ever thought of the expression when you're subtracting, right? And say you're going to subtract, say you have a 4 and you've got to subtract a 5 from it. You've got a bunch of other digits. So it's like 94 and you're subtracting the 5. In order to subtract that 5, you have to borrow 1 from the 9, right? Okay, right? Does it make sense? Y'all use the word borrow here, right? And so you borrow. Well, research found that students, especially really young students, had a big problem with that. Because what are you told when you are young? That if you borrow something, what?
You have to give it back aside.
You have to give it back, right? And you don't ever do that when you subtract. So little kids were thinking, I can't borrow from the 9 unless I give it back later. And so they had a lot of trouble with that expression. Isn't that funny? And so it makes perfect sense. So always ask those questions, because remember, I assume that definitions make perfect sense to me because I made them up or I've heard them very, very often, right? But when something's new, you should always make sure to clarify. Excellent job. Okay? I love that story too.
Oh, that's cute.
Okay, so what if the wind was going 2 times W knots and the motor was 10 knots? We could create an expression to represent that. 2 times W plus 10. Okay, all right.
So the only difference is it doesn't have an equal.
Exactly. Notice there's no equal symbol, otherwise that would turn it into an equation. Excellent. How about 5 times a number? Do I know what number? Nope. But I know that I want to multiply it by what? By 5 in the bottom. I did them out of order. By 5. So 5 times a number would be just 5 times X or 5 times Y. Or do you have a favorite letter?
G.
G? 5 times G then. Who cares, right? Okay, good. If you want to say some number plus 1, some number, do I know what number? Nope. So in this case, they're calling it X. But they want to then add 1 to it. So if you add 1, that makes it X plus 1. Now you need to be careful, though, because of the order. Now, not in addition. Do you remember that when you're dealing with operations, does order matter when you add? 2 plus 1 is 3. 1 plus 2 is still 3. What other operation can you do where the order doesn't matter? Okay, yeah, multiplication. 2 times 3 is 6. 3 times 2 is 6. But 3 minus 1 is 2. Is 1 minus 3 also 2? No, what is it? You remember? Negative 2. So, with subtraction and, what's the other? Division, right? Because 4 divided by 2 is 2, but 2 divided by 4 is 1/2 when you reduce it, right? It's 2 over 4, which divides into makes 1/2. So these two, if you don't get them in the right order, then it makes a huge difference. Well, if it makes a difference sometimes, would it be smarter to just think about it making a difference always, or to have a special rule sometimes?
Special rules. Always.
Always. It would be so much easier to have one rule that works for everything than 15 different special rules, right? Okay? So think about order makes a difference, right? So if I say some number, okay, plus 1, the sum number comes first, doesn't it? Okay? If I say 1 plus some number, then I should put which thing first?
1.
The 1 first. Okay? And if you get in the habit of doing that, when you do get the ones that have to be in a specific order, you'll already be doing it naturally. Okay? Excellent. Okay? So here you go. This time, we're going to add some more unknowns. We're going to start paddling this boat as well. So now we have the motor, which goes at a constant speed of what? 10. The wind, which we're going to somehow double because we've got 2 sails, so it doubles it. Okay? And the oars, or the paddles, which we're going to use. Do you think if you're paddling a boat that you go at a constant speed all the time, the whole time you're paddling? No way. You might start off strong, and then what happens? You get tired fast, right? So it's not going to be constant. Even if you really concentrate, it's never going to be a constant. So you'll see what they've done here is they use W for wind speed, P for paddles, and then the 10 comes from the motor. Okay? And 2 sails is how they're doubling the wind. Yes?
Well, the wind won't be the same as well because wind can be different.
Exactly. So that's why we don't have a number for wind, right? We just have a W. Yeah? So we have W for wind because we don't know, right? It can go faster or slower even while you're sitting in the harbor, couldn't it? Sometimes it blows very quickly. Sometimes it blows very slowly, lightly. Or it could do what? Turn around and blow against you, couldn't it? Okay. Which in case that would make it what kind of number then for your speed?
Minus.
A negative number. Yeah, minus number. Good job. Okay. All right. So now your total speed is 2 times the wind, right? Because we have 2 sails, plus the 10 for the motor, plus P for the paddling. Okay? So you can have more than one unknown in a sentence. Okay? And an expression is a sentence. Look at this one. You have 1 plus y minus 2 times y. So the y appears how many times here?
2.
Twice, right? Well, if you have y appear twice, that's fine. It can happen. But if you use the same letter, then it has to represent the same value. Exactly. The same number. So if y is 3 in one place, then what? It has to be 3 in the other place. Good job, guys. Excellent. Okay? Now, what if you put a second set of paddles? You have P plus another P, or you could write that as 2 P's, 2 times P, right? Because remember that anytime you have things added together more than one time, that's the same as saying 3 times that many, right? Okay, excellent. Good job. Okay, now, I'm a dog. True or false? Good. I'm glad you looked at the picture first. Good. Yeah. So in this case, I can't use the same label. So I couldn't use D for both of them, right? What could I do?
D and Y.
D and Y or D and C or D and K if it's a kitten, whatever, right? Or X and Y. They don't have to be descriptive, do they? Okay? Excellent. But you got to use different ones. Okay? And if you have the same letter in the same sentence, it has to be the same value. So, if you use X to be 5, then X has to be 5 when? Every time you use it in that sentence. Okay? What if it was a different sentence? Then who cares? It's a new game, right? All right? So how do you feel about a variable? Good. All right?
I love that.
Well then, the sloth says goodbye.
I can't live without you.
You can't live without her. She'll be back.